Welcome students. This is again the lecture for CSC 2 for Engineering Mathematics 2. So the today's topic is t-test for testing the significance of simple correlation coefficient. So first of all I am going to discuss with you some concepts that we have discussed in my previous lectures. I have discussed with you the various types of testing. Basically, I have started with the large sampling test, which is also known as Z test, and then I have discussed with you the small sample test, that is known as T test also. So, large sample, basically, again, I am telling you the samples having size greater than 30, and the small samples, they are those samples in which this number of observations they are less than 30. For large sample we always use the Z test, and for small sample we always use the T test. So these are the very basic things for testing. So these things you have to keep in your mind, and I am repeating these things, these basic things again and again in my every lecture, because these are the basic essentials of testing. So we have discussed many applications of t-test also. That is, t-test is also used to check the difference of mean or difference of mean between sample and population, or difference of mean between the two samples. Then we have also discussed the application of t-test for checking the difference of the standard deviation between two samples, or the standard deviation between a sample and a population. So here the last application of t-test is that I am using over here is that t-test is also used to check the significance of simple correlation coefficient. Students, I have also discussed with you the Karl Pearson's coefficient of correlation, which is given by small r. That we have discussed so many formulas in the class also. That is, correlation coefficient is given by these. That is the relationship between the two variables x and y, say statistically. So here I am going to discuss the difference of the correlation coefficients of two samples, or we can say this, the correlation coefficient between a sample and the population. So let us discuss what is the actually we are doing, then I'll discuss with you, or I'll explain the concept with the help of the examples. So what is the t-test for testing the significance of simple correlation coefficient? So you can read from your screen also. The one of the application of t-test is that we can test whether the correlation in population from which the sample has been taken is significant or not. That is, the sample correlation coefficient differs significantly between the another sample's correlation coefficient, or we can say this, the sample correlation coefficient how much differs significantly or insignificantly manner from the population's correlation coefficient. So usually what I used to take, as I know, the very much first step of my any kind of testing, whether large or small sample testing, to set up the null hypothesis. So in this case, what I usually set up my null hypothesis given by h naught, that is rho is equal to 0. So rho here I am using for population correlation coefficient, and small r here I am using for the samples correlation coefficient. So I usually take rho is equal to 0. What does it mean? That variables in the population, they are uncorrelated. That is, there is no relationship between the variables in the population. So what will be the alternative hypothesis, which is complement to the null hypothesis, that is rho is not equal to 0. So the next step for the calculation, the t statistic that you have to keep in your mind, that is r minus rho under root n minus 2 over under root 1 minus r square. As I have set up my null hypothesis h naught rho is equal to 0. So I'll put the value, or I'll use the value rho is equal to 0 over here. So the formula reduces to r under root n minus 2 over under root 1 minus r square. Now I have written the meaning of each and every symbol or each and every variable which I am using over here. N means sample observation, sample size, or we can say this, the number of observations in the sample. R means correlation coefficient of the sample, and rho, which I have used in the above. Here I can put the cursor also. Rho is the population's correlation coefficient. And in this case, after that, doing all the calculation, I will make the comparison between the calculated value and the table value, and for that I require the degree of freedom. And in this case the degree of freedom is n minus 2, where n is again the sample size or the number of observations in the sample. So let us elaborate this concept. Hope so this concept or the formula or the process of doing testing using t-test by significance of simple correlation coefficient is clear to you. So let us elaborate this concept with the help of the examples. So the very much first example that I am going to discuss with you, please read out the statement. The statement is correlation coefficient of 27 pairs of observations from a bivariate normal population comes out to be 0.6. So we are having 27 pair of observations. So here n is equal to 27, means the sample size, the number of observations used in the sample, they are given to you 27, and their correlation coefficient is given to you 0.6, that is r is equal to 0.6. So question is, can we say that correlation is significant in the population? That is, we just have to check whether correlation coefficient, how much differs significantly or insignificantly manner from the population's correlation coefficient. So first of all, for doing the process of testing, I will set up my null hypothesis. So the null hypothesis that I have already discussed with you in my previous page, that we always have to take null hypothesis. In this case, rho is equal to 0, that is population correlation coefficient is 0, means to say there is no relationship between the entities or between the variables used in the population. Or you can read also, that is correlation coefficient is not significant in the population, it's very insignificant figure. So the second step is to set up the alternative hypothesis. So alternative hypothesis, as you know, it is the opposite or it is the complement to the null hypothesis. So H1 will be rho is not equals to 0. Now I will use the t statistic, the formula that I have used or I have discussed with you recently, that t is equal to r under root n minus 2 over under root 1 minus r square. So I will put the value of n as 27 and r as 0.6 as given in our question. So I'll put the values. You can verify from the calculator or you can check your calculation. The t comes to be 3.75. So this is your calculated value. If this value is negative, then you will make it positive by taking the absolute value, by taking its mod, or you can say this by considering its absolute value, and then you will make the comparison of this absolute calculated value with the table value. So for the table value, I require the level of significance. I have already discussed so many times, if the level of significance is mentioned in the question, then you just have to follow that level of significance. Otherwise, its choice is yours. You can take 1% or you can take 5% also. So I am using over here 5%, but the degree of freedom you have to keep in your mind for each and every application, because degree of freedom is varying or it is different for each test. So here for correlation coefficient testing, I am having the degree of freedom as n minus 2. So here n is 27. So the degree of freedom that I am going to use is 27 minus 2, that is 25. So at 5% level of significance with degree of freedom 27 minus 2, that is 25, the table value is given by 2.06. We can verify it from our table values also. Now our next step is to calculate or to compare the absolute calculated value with the table value. So the absolute calculated value is mod 3.75, that is again 3.75 with the table value. And what is the table value? It is 2.06. So our calculated value is greater than the table value. It means we will reject H0, that is I will reject the null hypothesis. Means to say the assumption that I am taking initially, that is wrong. So it means alternative hypothesis is true, that will be accepted. So means to say the correlation coefficient is insignificant in the population. It is not significant in the population because our assumption was wrong. Null hypothesis was wrong. So if null hypothesis is wrong, then what obvious? Its opposition or its complement statement will be correct. So its complement statement is H1, that is the alternative hypothesis, where rho is not equal to 0, which means or which indicates that correlation coefficient is not significant in the population. Hope so you have very much good idea or very clear idea how to check the correlation coefficient significance in sample or in population, whether the value is significant or not. I'll also discuss one more application, or I will explain this concept with the help of one more example with you. So let us read the example. So the question is, you can read the statement uh, is find the least value of r. You have to tell the value of r now, that is r means correlation coefficient in the sample. In a sample of 18 pairs, means sample size is 18, of observations from a bivariate normal population significant at 5% level of significance. Now here the question is very tricky. In our previous question we just have to check whether the population correlation coefficient is significant or not. Here already given that the population's correlation coefficient is very much significant, that is rho is not equal to 0. So we just have to find the value of r, means we have to accept the null hypothesis. Here the null hypothesis is very much true, and the number of pairs of observations in a sample is given to you 18. Okay, so what we have given, you can read the solution, that n is equals to 18. Now first of all I will calculate its table value. So what is the table value? For table value I require the level of significance and degree of freedom. In this case I have discussed with you what is the degree of freedom. It is n minus 2, and what is n? It is 18. So from table, at 5% level of significance with degree of freedom n minus 2, what is n? 18. So 18 minus 2 is 16. The table value you can check from your tables, that is 2.12. Okay, then now I'll calculate or the values of table value, or sorry, calculated value or the of t statistic, accordingly the values which we have given in the question. So we are here, the null hypothesis as rho is equal to 0, that is population correlation coefficient is equal to 0, as we usually take many yes, as we have discussed initially in the starting of this lecture, that we always have to take null hypothesis as rho is equal to 0. Now I will calculate t statistic. The t statistic is given by r under root n minus 2 over under root 1 minus r square. Now in order that the calculated value of t is significant at 5% level of significance, the value will be significant only if the calculated value is greater than the table value, otherwise the value will be insignificant. If the value is 0, then the value will be insignificant. So you always keep to have remember in your mind that the calculated value of t is always significant if and only if the calculated value of t is greater than, I am writing over here the notation t is 0.05. It means the table value of t at 5% level of significance with this much degree of freedom. This much degree of freedom means it depends upon the application which you are using, because degree of freedom varies in each and every application. So I have put the value of r over here, n as 18, and r I'll take the same, I'll write r as r under root 16 over 1 minus r square is greater than 2.12. So if I square on both sides, 16r square is greater than 2.12 whole square, and the factor which I have written over here in denominator, it will go on the right hand side and it will reduce to 1 minus r square, because I have done squaring on both sides, so under root will be vanish. So after simplifying, you can check, I am getting r square is 0.2192, taking square root on both sides, so I am getting mod r. I just have to take this positive value, that is 0.4682. So in this case the absolute value of r should be greater than 0.4682. So the question was the least value of r. So the least value of r is 0.4682, in order that the sample of 18 pairs of observations from a bivariate normal population significant at 5% level of significance. So hope so this application is also clear to you. So this is the one more application of t-test. So I have discussed with you the applications of t-test, basically for the difference of mean, for the difference of standard of deviation, and the correlation coefficient between two samples, sample 1 and sample 2, or you can make the comparison of these three things between one sample and the population, whether the difference is significant or insignificant. So these are the basic applications of the t-test, which are very much important, equally important from examination point of view. So if you have any kind of doubt in this lecture or any application of t-test, you can ask me. You can ask your query through WhatsApp, through your call, or you can mail me also at my mail ID I have already given to you in my WhatsApp group. So onwards tomorrow I will discuss with you the F test, in which I will discuss the difference between the means and then the standard deviations. That I'll discuss whether the population that I'm using in my testing, it follows normal distribution or not. Thank you.